Hi, welcome to the F Sharp for Beginners tutorial series. This is the second part. So we are going to look at these list of topics. The first one is F Sharp data types that you have to know what is supported and what's not. And then the let keyword, which is the important one in F Sharp. And then we have recursion. So you will learn about how you can do recursion in F Sharp. Then the final one is pipelining. This is a little bit higher construct for the language, but still knowing in the start itself will actually help you enjoy more of the language, and that's why I've included that here. Okay, so for the first topic we have the data types. F Sharp is a pure .NET language, so all the data types are just straight CLR types. You don't have to learn anything new about that. And one important factor that you have to know is F Sharp considers data types as very serious. Like if you declare a value as a float, then it stays as float. You can't just use that as an integer unless you forcefully typecast it. Like unlike in C Sharp, where you can declare a double and you can simply use that as an integer. So I've listed out all of these in the document that I will also provide usually in my tutorial series. You can check this out. I've taken this from Studio Comma, which is a nice site for learning F Sharp too. So these are the data types that are supported in .NET, and you have the F Sharp type and its equivalent symbol that you can use for declaring your data. The next part of the topic is the let keyword. This is the first keyword that you should and must learn in F Sharp, because this is where it allows you to declare variables and functions alike. So you can just have let x equal to 5, or you can also have let x off equal to 5. The difference between the two is the first one is a variable and the second one is a function. There is also one more thing that you have to understand here. It's let is more of a binding than a declaration, because in F Sharp everything is immutable. So you actually bind that object to the value, and it doesn't change for its lifetime of the scope. You can also have mutable objects. Just declare the keyword mutable, and that will allow mutation for that particular object. Let us check out some code stuff now. So the syntax is let x equal to 5. So we have 5 as an integer, so automatically F Sharp infers x1 as an integer. So likewise in the second one you have 5 dot. It can be any of the data types that we have learned in the first part. So 5 dot infers it's a float. And then you have a method called add that accepts an integer and returns an integer. So if you see here, it says integer, and there is the last integer that is the return value of the type. The reason why this add method is inferred as integer is because you're passing an integer value here. If you change this to float, let's do that by adding a dot. Now automatically add becomes float. That's the way it is. You can also add constraints in the method directly, saying what the parameters are. So then F Sharp doesn't require any type inference at that point. So now if you say it's float, it's star float, and there's a float. Okay, let's just do a simple execution of this in the F Sharp interactive. So quickly doing an alt enter, you just see here things are declared, and you have an add. The value v is equals 30, so it prints out 30. Let's look at the recursion functionality in F Sharp. Recursion is a primary functionality of any functional language. Okay, F Sharp allows you to define recursive bindings using the rec keyword. There is also a variant of recursion called tail recursion, which allows you to generate optimized recursive loop in the IL code, but you still will be writing a recursive function, but the generated output is different. I mentioned some more details on how the IL infers using ILSpy in my document. We'll look into the code now so we'll get better understanding of it. Okay, let's accept this. Okay, like in the example I've used is a factorial, like everybody does. I have a factorial of n is an integer. So when n reaches 0, then I return 1. Otherwise, I just multiply with a reducing factor of 1 every time. So let me send that to my interacting one. That's all. So it's as simple as that. I just express my function in a very simple declarative way. This is how you do it in F#. Like I said, there is one more variant of F# called the tail recursion, which allows you to generate optimized code. The tail recursion is a specific feature of F# that requires just one extra parameter in your recursive method, an accumulator that accumulates your previous value and passes that as an input to the next recursive call. Okay, so here I have a value ACC that's actually sending me the last value as an input to the other value. Okay, there is just this one difference, so the outputs should be the same. If you look at that, I have mentioned these things in the document, that how things work out. This is the generated output of a tail recursive function. If you look at that, it has a while loop generated. I mean, the IL code is different, but this is how you visualize that in C#. I thought C# code would be much easier for you guys to understand. Okay, so there is one more method that I have just mentioned here for your fun. It's just for fun, you know. You can write very nice, concise code using the recursive functionality. If you look at here, we are using seek module classes. We'll look into these things in the future, but right now just try to understand that. So this method is just a 3-line method that will append all my files and subfolders from a particular directory. Okay, I need to add system button here. Okay. Oops. So get files within a sequence of strings. I can say get files of SQL work/training. This is my training folder. That's all. It's as simple as that. Like it goes into each and every file, each and every directory, and maps that to my output as a string value. So it's a recursive method because here I call a recursive function again, and it ends when my directory files are over. And then this is a recursive function for the Euler problem 15. I've taken that from a blog. You can just check it out. It's a nice way of defining things. So the last topic in this series is the pipelining functions. Pipelining helps you to create a sequence of methods. Like you take the output of one method and provide that as an input to the other method. So this helps you write a sequence of functions very nicely, and you really would it really makes the code readable. You can think this as the fluent pattern that is being followed in the LINQ framework in C# and VB.NET. So F# allows you to define functional operators. Basically, the pipelining operator in F# is also a functional operator. So this is how it is defined. Like let pipeline paramount x of f is equal to f of x. It means a function is going to be executed with the input from some other function. So I have defined most of my samples in the document. You can check this out. Like let's do this. Let's declare some data 1 to 10, and then let us filter values that are less than 4. So you should be getting 1 to 3 there. Since this is a seek, it actually evaluates when you access the object. Okay, so if you look at this, we are using a pipeline method. So I'm providing data as the input to my seek.filter function. Usually if you have a method call, you should be providing two values. If you see that, you have a t and then it returns a boolean. But pipelining allows you to write in a nice concise way. Let's add one more pipeline method. You just call sum, then what it does is it sums up all the values that are less than 4. Now you can also have your own functional operator. For instance, like let us say we are defining a new functional operator called plus equal to, which does the same functionality of a pipeline operator for the default F sharp. So I say plus equal to is this, and then I replace all my pipelining operators with my plus equal to pipeline operator. Okay, I execute the same object and it gives me the same output. This is the power of F sharp. You can have your own functional operators which does a lot of stuff under the platform and just lets you write expressive code. So we have come to the end of our session. Thanks for joining me. We'll look forward for the next sessions. Thanks a lot. Bye.